Hello, and welcome to tonight's Space Sleep Story. If you appreciate what we do here, please like or subscribe for future relaxing nighttime space journeys. Tonight we embark on the return journey from Mercury after 30 days exploring the innermost planet. We ascend from the polar rim base, depart Mercury's gravity well, and begin the 26-month voyage home, carrying 85 kilograms of precious samples. So settle into your most comfortable position, close your eyes, and prepare for this bittersweet farewell and homecoming journey. Before we begin, let us prepare your body and mind with gentle breathing. Take a slow, deep breath with me now. Inhale gently for 4 counts, drawing peace into your lungs. Hold the stillness within you. Exhale slowly for 6 counts, releasing the day's tension. Feel your body settling into complete relaxation. Your shoulders dropping, your jaw unclenching, your mind becoming calm and clear. Perfect stillness surrounds you. Another gentle breath as we continue our preparation for tonight's journey. This time, notice how your chest rises and falls with natural rhythm. Breathing in the vast peace of space. Holding the moment between breaths, where time seems to pause. Breathing out everything you no longer need. Feel the stress of the day leaving your body with each exhalation. With each breath, you release a little more into relaxation, settling deeper into your bed, becoming heavier, more peaceful, completely at ease. After 30 days on Mercury's surface, the mission is complete. Final surface activities finished yesterday, equipment powered down, experiments documented, samples secured in hermetically sealed containers. Today begins the ascent to orbit, reunion with the Orbital habitat crew, and departure for Earth. The lander sits on the polar rim where peaks of eternal light meet permanently shadowed craters. Inside the cramped cabin, 2 crew members perform final systems checks. Propellant loaded, 8.5 metric tons of hypergolic fuel, nitrogen tetroxide, and hydrazine, requiring no ignition system. The ascent stage weighs 4.5 tons dry mass, including crew, samples, and return equipment. Delta V capacity, 3.2 kilometers per second, providing margin above the 3.0 requirement. The ascent engine must fire continuously for 7 minutes. No restart capability exists. This single burn either succeeds completely or the orbital crew will need to execute a rescue mission. But confidence runs high. The systems have been tested exhaustively, margins calculated precisely. Apollo demonstrated these techniques decades ago on the Moon. 7 minutes from surface to orbital insertion, exactly as planned. Mercury's escape requirements differ from other worlds you might imagine. Departing from this surface requires 3 kilometers per second of velocity change. This exceeds the Moon's 1.7 kilometers per second, but falls below Mars's 4.1. Mercury's gravity measures 0.38 times Earth's pull, identical to Mars, despite their vastly different sizes. The ascent trajectory will follow a carefully optimized path. Vertical climb for the first 30 seconds, clearing terrain, then a pitch-over maneuver, transitioning to prograde flight. The gravity turn will optimize fuel efficiency, letting Mercury's gravity help shape the trajectory toward orbital insertion. Communication crackles between lander and orbital habitat. Lander, this is Habitat. We're tracking you for launch window in 90 minutes. Rendezvous trajectory calculated and verified. All systems ready to receive you. The voice sounds familiar, warm. Orbital crew waited 30 days while the surface team explored craters, sampled ancient ice, measured magnetic fields from the ground. Now, reunion is imminent. 6 crew members will be together again after a month of separation. Habitat acknowledged. Looking forward to having the whole crew back together. Sample containers are secured and ready for transfer. The countdown proceeds with calm precision. T-minus 10 seconds. Engine ignition sequence start. Through the viewport, Mercury's gray, cratered surface stretches to the curved horizon. Boot prints from yesterday's final surface walk are still visible in the regolith. 3, 2, 1. Liftoff from Mercury. The ascent engine ignites with 45 kilonewtons of thrust. Against the 4.5 metric ton mass, this creates 1 full g of acceleration. Combined with Mercury's 0.38 g surface gravity, the crew experiences 1.38 g total, feeling 2.6 times heavier than standing on the surface. The lander climbs vertically. Surface dropping away, boot prints visible for seconds, then dust patterns, then cratered terrain spreading wider. The curved horizon becomes more pronounced with each passing second. Altitude 2 kilometers, velocity 300 meters per second vertical, initiating pitch-over maneuver. The lander rotates smoothly, nose pitching toward the orbital direction. Now climbing diagonally, gaining both altitude and horizontal velocity simultaneously, the gravity turn optimizing every kilogram of precious fuel. Below, the landing site recedes. Chao Meng Fu crater rim where peaks catch eternal sunlight. Altitude 50 kilometers. Velocity 1.2 kilometers per second. Mercury's curvature is obvious now, the surface extending to a horizon 400 kilometers distant. The landing site lies behind, a tiny patch of disturbed regolith marking 30 days of human presence. The permanently shadowed region, where ancient ice was sampled, appears as a dark patch even from this altitude. Michael Collins once described lunar ascent, most peaceful part of mission, moon receding behind, Earth approaching ahead, knowledge of success complete. Today, that same peaceful satisfaction fills this cabin. Mission objectives exceeded, samples secured, ascent proceeding exactly as planned. Altitude 150 kilometers. Velocity 2.2 kilometers per second. Approaching orbital insertion altitude. Mercury now appears visibly spherical below, no longer a flat landscape, but clearly a world. The Terminator line cuts sharp between blazing day and absolute night. No atmosphere to soften the transition. Polar ice deposits gleam bright against dark shadows. Engine cutoff in 30 seconds. The engine's steady thrust has pushed continuously for 6.5 minutes, transforming surface velocity into orbital momentum. Engine cutoff. Altitude 200 kilometers. Velocity 2.4 kilometers per second. We are in orbit around Mercury. Seven minutes from surface to space. The ascent succeeded perfectly, inserting into the planned 200 by 15,000 kilometer elliptical orbit. Now begins the rendezvous sequence. Habitat visual 50 kilometers ahead and above us, closing rate 20 meters per second. The orbital habitat appears as a bright star against the black, slowly growing. Final approach will take 5 hours as phasing maneuvers circularize the lander's orbit to match the habitats. During those hours, systems checks, decompression from surface gravity back to microgravity, reviewing tomorrow's departure timeline, securing sample containers for transfer. Bodies adapting after 30 days at 0.38 G. Habitat, we're 500 meters out, closing 2 meters per second. Final approach manual. Through the viewport, the orbital habitat grows. Cylindrical pressure vessel, solar arrays extended like wings, heat shield oriented sunward, protecting against 6.7 times Earth's solar intensity. Familiar home after a month away. Docking approaches, gentle contact, latch mechanisms engaging with soft clicks, pressure equalization between vessels. The hatch opens. Orbital crew welcoming surface crew, handshakes becoming hugs, 6 people reunited. Welcome back. Mercury surface samples? Secured. 85 kilograms, most precious cargo this spacecraft has ever carried. Tomorrow, we start the journey home. The next day, all 6 crew assemble to review the departure trajectory. Today we leave Mercury orbit and begin the 2.2-year journey to Earth. The departure burn will occur at apoapsis, the orbit's highest point, 15,000 kilometers above Mercury's surface. 2.1 kilometers per second of delta V applied over 14 minutes of gentle 0.2 g acceleration. This burn represents the point of commitment. After it, the crew is bound to Venus flyby and Earth return. No turning back, only moving forward toward home. Eugene Cernan once reflected on leaving the moon. Bittersweet. We'd accomplished everything, but leaving felt like abandoning something precious. Two trajectory options existed in the planning phase. A direct Hohmann transfer to Earth would require 2.8 years and 8.5 kilometers per second total delta V, exceeding the fuel budget. The chosen path uses a single Venus gravity assist, reducing the journey to 2.2 years and 6.8 kilometers per second. Venus will be encountered 18 months from now at 500 kilometers altitude. The flyby will bend the trajectory outward, providing 2.5 kilometers per second equivalent velocity change without expending any fuel. Mariner 10 proved this technique in 1974. Messenger used it from 2004 to 2007. Today, this proven method enables homecoming. Harrison Schmitt, the only geologist to walk on the moon, once said, "Sample boxes were more precious than our lives. Moon's secrets packed for Earth's laboratories. Protecting them was sacred duty." That same dedication fills this mission. 85 kilograms of Mercury material rest in sealed containers. 45 kilograms of regolith and rocks from various surface sites. 25 kilograms of ice cores from permanently shadowed craters maintained at -170 degrees Celsius. 15 kilograms of exosphere atoms collected on charged plates. Total scientific return value? Estimated $500 million minimum. But the knowledge potential is truly priceless. T-minus 30 minutes to trans-Earth injection. All crew secure for acceleration. Sample containers locked in vibration-isolated storage. Every system checked and rechecked. The next engine firing will last 14 minutes, gentle but sustained, accumulating 2.1 kilometers per second of velocity change. After this burn, Mercury becomes memory. The crew will watch it shrink from world to disk to star to invisible, carried forward only in the samples traveling with them, in the data recorded, in the experiences lived. Those rock cores, ice samples, exosphere captures, they are Mercury traveling to where no Mercury material has ever been. T-minus 60 seconds. Engine gimbal check complete. Ignition sequence armed. Through the aft viewport, Mercury hangs. Small gray sphere, the sun enormous beside it even through heavy filtering. After 2.5 years approaching this world, 8 minutes inserting into orbit, 30 days exploring the surface, 7 minutes ascending, 1 day in orbital operations, now comes departure. Chris Kraft, legendary flight director, once noted, "Mercury departure windows. Miss your 14-day window? Wait 5 months." That kind of constraint demands absolute reliability. Today, the window is open. The systems are ready. The crew prepared. Goodbye, innermost planet. Engine ignition. Gentle push. 0.2 G feels mild after the ascent's full G, but this will be sustained. Duration matters more than intensity. Velocity increasing. Mercury orbit, 2.4 kilometers per second. Current velocity, 2.8, 3.1, 3.5 kilometers per second. Climbing out of Mercury's gravity well and the sun's inner grip simultaneously. Through the aft window, Mercury shrinks perceptibly. Was a disk filling the view, now baseball-sized, soon star-sized. The sun still appears enormous, requiring filtering, but beginning its long, slow diminishment toward the familiar Earth view size. "7 minutes pass in steady acceleration. Velocity 4 kilometers per second, halfway through burn. Mercury through the aft window continues shrinking, transforming from world to distant object. The cratered surface that was walked upon, studied, sampled, now recedes into astronomical distance. James McAdams, messenger navigator, described inner solar system navigation. Like sailing close to a whirlpool, Sun's gravity dominates everything. Venus gravity assist during return is mandatory, not optional. Mathematics and orbital mechanics guarantee safe passage, but the tolerances remain unforgiving. precision navigation across millions of kilometers. "14 minutes. Engine cutoff. Velocity 4.5 kilometers per second relative to the Sun. Mercury escape achieved. Trajectory established toward Venus flyby in 18 months. Earth return in 26 months. Trans-Earth injection complete. We're going home." Through the telescope now, Mercury appears as a gray disk, cratered surface barely visible at this distance, polar ice deposits invisible. In 6 hours, it will be a naked-eye star. In 2 days, lost in the sun's glare. Leaving a world walked, craters studied, ice sampled, the sun observed from the unique vantage of 0.38 AU. Reflection settles over the crew. Mercury taught profound lessons. Smallest terrestrial planet, holding vast complexity. Closest to the sun, yet harboring ancient ice in permanent darkness. Geologically quiet, yet hollows possibly still forming today. Weak magnetic field, yet liquid iron core somehow convecting. Overlooked planet, revealed as archive of solar system history. Laboratory of extreme conditions. Opportunity for transformative discovery. The crew explored a fraction of one polar region. Mercury holds centuries more discovery, waiting for future missions, permanent bases, sustained scientific presence. "7 days after departure, the first trajectory correction maneuver. Small burn, 50 meters per second delta V correcting injection errors. Even tiny errors at Mercury departure amplify over 18 months to Venus encounter. This correction ensures arrival within plus or minus 100 kilometers altitude, plus or minus 15 minutes timing. Navigation is cumulative precision, mathematics enabling safe passage across 200 million kilometers. Earth tracking stations measure spacecraft velocity to 0.1 millimeters per second precision using Doppler shift. Transmitted radio frequency shifts proportional to velocity along the Earth spacecraft line. Over weeks of tracking, trajectory is determined to plus or minus 1 kilometer position accuracy. The communication signals take 8 to 15 minutes each way, depending on Earth spacecraft geometry. Conversations with mission control become asynchronous exchanges, questions and answers separated by the speed of light across astronomical distances. But the data flows continuously. Telemetry confirming systems nominal, trajectory updates refining the path, science teams already anticipating sample analysis. Nancy Chabot, who helped discover Mercury's ice, said, "Ice cores possibly 3 to 4 billion years old. Single core could revolutionize formation models." The psychological transition from exploration to return. Outbound journey had destination anticipation. We're going to Mercury, curiosity and preparation. Return journey has homecoming drive. We're heading to Earth, equally powerful but different emotional texture. Satisfaction replaces nervousness. Completion replaces preparation. Anticipation of reunion replaces anticipation of discovery. Jim Lovell once reflected, "From the moon, Earth behind your thumb at arm's length, all history, all life on that fragile sphere, makes departure feel selfish, return feel like duty." Bringing knowledge back to that world, sharing discoveries with humanity. Crew dynamics after shared achievement. 6 people, 5 years together. 2.5 years outbound, 1 month surface operations, with the crew split between lander and orbit. 2.2 years return. Shared achievement. First humans on Mercury. Samples collected. Mission successful beyond requirements. But return journey is also decompression time. Reflecting on what was accomplished. Processing experiences that will shape the rest of their lives. Preparing for eventual separation. After Earth landing, the crew will likely disperse. Different assignments, families, futures. These months represent the last time this team exists. Sample cargo significance deepens with every kilometer from Mercury. 85 kilograms in sealed containers. Regolith showing low iron, high magnesium composition, unlike any other terrestrial planet. Ice cores with layered structure, each layer recording a deposition event millions of years apart. Exosphere atoms representing Mercury's tenuous atmosphere. Rocks from calorous basins, smooth volcanic plains. From lobate scarp walls exposing deep crust. From hollow interiors revealing volatile-bearing minerals. This cargo's value measured not in dollars, but in knowledge potential that will write Mercury's history for decades to come. Earth laboratories will analyze these samples for generations. Isotope ratios revealing formation conditions. Mineral composition showing unique melt chemistry. Magnetic remnants recording ancient field strengths. Organic compounds, if any, survived. Impact melt chronology, dating the bombardment history. Volatile distribution, proving delivery mechanisms. David Blewett from the Messenger imaging team said, "Only samples can resolve questions orbital data created. Are hollows actively forming or ancient? What volatiles drive formation? When did volcanism cease? Laboratory precision impossible from orbit." Venus flyby planning occupies quiet hours. 18 months from now, Venus encounter. Approaching from the sunward side, interior to Venus's orbit currently. Passing 500 kilometers above the cloud tops. Gravity bending the trajectory outward toward Earth distance without expending fuel. Velocity reduction of 2.5 kilometers per second equivalent, the gift of planetary mechanics enabling homecoming. Venus will appear familiar. The crew flew by twice outbound, using Venus assists to lower orbit to Mercury. Now Venus one last time, raising orbit to Earth. Symmetry closing the loop. Earth remains invisible from here. Lost in the sun's glare, too close to the solar disk for safe viewing. But after Venus flyby, Earth becomes visible as a blue star, brightest object besides the Sun, growing imperceptibly brighter monthly. Final months will show recognizable features, cloud patterns, continents, the Moon orbiting. Home after 5 years. Sean Solomon, Messenger Principal Investigator, reflected, "Human mission returning samples completes investigation. Orbital reconnaissance plus ground truth plus laboratory analysis equals comprehensive understanding. That's exploration done right." Navigation plotted. Trajectory corrections scheduled. Sample preservation systems stable. Ice cores maintained at -170 Celsius using liquid nitrogen reserves. 60 kilograms with controlled boil-off over the 2.2-year return. Life support nominal. Exercise routine resumed. 2 hours daily, preventing further bone and muscle loss. The crew settles into cruise mode. Months of travel ahead. Nothing urgent. Just steady progress homeward through the inner solar system. Radiation monitoring continues. Accumulated dose so far, 3.2 sieverts outbound over 2.5 years. 0.1 sieverts on the surface for 30 days with habitat shielding. Estimated 2.8 sieverts for the return journey. Total mission, approximately 5.1 sieverts. Approaching, but within astronaut career limits. Medical monitoring required. Regular health checks. But the dose remains within acceptable bounds, the trade-off accepted for Mercury exploration, for bringing these samples home. Bone density tracking shows expected degradation. DEXA scans reveal 22% bone density loss after 3 years mostly weightless, plus the surface stay. Another 2.2 years will add 8 to 10% more loss. Total mission projection, 30% bone density reduction. This will require 6 to 12 months Earth rehabilitation. Calcium supplements, weight-bearing exercise, possibly pharmacological intervention. The skeletal system pays a price for planetary exploration. But the crew accepted this cost willingly, knowingly, for the privilege of being first humans on Mercury. Crew reflection during quiet hours. We walked on Mercury. Fourth celestial body humans have stood upon after Earth, Moon, and Mars. Innermost planet. Closest to the Sun. Most thermally extreme surface accessible to humans. Smallest regular planet. Ancient ice discovered. Solar features observed from unique proximity. Magnetic field measured from the ground. Mission objectives exceeded in every category. Success complete. Knowledge secured in these precious sample containers. Mercury's future extends beyond this first mission. Others will follow. Establishing permanent base near the polar ice deposits, mining water for propellant and life support, making Mercury sustainable. Building solar observation platforms exploiting the proximity to our star. Preparing missions deeper into the inner solar system, perhaps closer approaches to the Sun itself. Mercury isn't an endpoint. It's the beginning of sustained inner realm presence. Today this crew returns. Tomorrow others will stay. Your breath. 4 seconds in, 4 seconds out. Spacecraft velocity, 4.5 kilometers per second relative to the Sun. Distance from Mercury, 50 million kilometers and growing daily. Distance to Earth, 150 million kilometers and shrinking. Time to home, 800 days remaining. Timescales nesting within each other, breath within second, within day, within month, within year. All leading homeward. All moving toward reunion. Five-year mission approaching completion. Episode 35. 2.5-year journey to Mercury through Venus assists, thermal challenges, psychological adaptation to sunward travel. Episode 36. Orbital insertion, landing site selection, powered descent, polar rim touchdown. Episode 37. Surface exploration, ice coring, feature observation, mission success. Episode 39. Ascent to orbit, departure burn, navigation homeward, sample return. Complete exploration cycle demonstrated. This architecture applies to any solar system destination. Journey to distant world. Landing on extreme surface. Conducting science. Collecting samples. Returning with knowledge. Mathematics enables the journey. Engineering enables the landing. Curiosity enables discovery. Samples enable deep understanding. The complete cycle transforming exploration from achievement into advancement. The sun that dominates Mercury's sky also warms Earth. Same star, different perspectives. Experienced both Earth's gentle 1,361 watts per square meter and Mercury's intense 9,100. Now traveling back toward familiar warmth, carrying knowledge of extreme environment survived and studied. Samples of a world where day temperature reaches 430 degrees Celsius and night plunges to -180, bringing pieces of eternity to the living world. Mercury waits behind, continuing its slow 58.646-day rotation. Polar ice preserving billion-year history in permanent shadow. Hollows possibly still forming through processes not yet fully understood. Magnetic field generated by mysterious liquid iron core. Ancient world enduring. This crew visited briefly, walked carefully, sampled respectfully. Mercury continues eternally. The samples are pieces of that eternity, now traveling homeward. Sample containers secured in scientific bay. Systems humming quietly. Trajectory stable and verified. Earth ahead, invisible but approaching inexorably. Mercury behind, visible through telescope but shrinking daily. Venus ahead, 18 months until encounter. Journey peaceful. No urgency, just steady progress through the inner solar system. Time for reflection. Time for rest. Mission successful. Exploration complete. Return underway. Tomorrow brings 799 more days of travel. Then Earth re-entry. Landing. Sample transfer to laboratories. Crew reunion with families. Debriefing. Rehabilitation. Next assignments for some. But tonight, rest in the journey rhythm. Satisfied by achievement. Peaceful in the knowledge of mission accomplished. Mercury's secrets safely stowed. Earth growing closer. Journey continuing. Peaceful motion through space. Steady homeward progress. Samples preserved perfectly. Knowledge traveling home. Floating in microgravity. Complete weightlessness. Systems humming quietly. All nominal. Navigation precise. Course verified. Stars surrounding you. Infinite cosmos. Crew resting peacefully. Mission on track. Earth awaiting ahead. Home approaching. Time flowing gently. Days passing. breathing slowly. Deep relaxation. Perfect silence. Utter peace. Drifting in space. Gentle motion. Everything secure. All protected. Journey continuing, homeward bound. Complete stillness. Total calm. Rest now. Sleep peacefully. Floating gently, drifting deeply. Stars watching. Cosmos embracing. Mission complete. Rest earned. Sleep now. Dream peacefully. Deep rest, infinite peace. Peaceful sleep, complete rest. Gentle dreams, safe journey. Rest deeply. Sleep well. Perfect peace. Total rest. Floating softly, drifting away. Deep sleep. Peaceful rest. Complete relaxation. Total peace. Infinite calm. Eternal rest. Sleep now. Rest completely. Peace surrounds you. Sleep deeply. gentle rest, perfect sleep. Drifting peacefully, sleeping deeply. Total stillness, complete peace. Rest now. Sleep well. Infinite space surrounds. Complete safety. Journey peaceful. All secure. Drifting homeward. Earth ahead. Sample cargo safe. Mission succeeding. perfect trajectory. Gentle progress. Stars eternal, peace eternal. Rest deeply, sleep fully. Floating peacefully, completely relaxed. Time suspended, peace absolute. Breathing gently, resting completely. Mercury behind, Earth approaching. everything calm, all peaceful. Deep rest, complete peace. Safe journey, peaceful sleep. Infinite stillness, perfect rest. Sleep deeply, dream gently. Total peace, complete rest. Stars above, peace within. Drifting softly, sleeping soundly. Rest now. Sleep peacefully. Gentle sleep, deep dreams. Perfect rest, total peace. Sleep now. Rest completely. Infinite calm, eternal rest. Deep peace, complete sleep. Peaceful dreams, gentle rest. Stars watch. Sleep safely. Rest deeply. Sleep well. Total stillness. Perfect sleep. Floating gently, resting completely. Sleep now. Dream peacefully. Deep rest, infinite peace. Complete calm, total rest. Peaceful sleep, gentle dreams. Rest now. Sleep deeply. Perfect peace, complete rest. Sleep well. Rest peacefully.